Today, I'll be presenting an overview of our cloud based system, how it's designed, implemented, and the benefits it brings to the table. These are our team members. In an era where data driven research and AI workloads are becoming increasingly complex, having a scalable, efficient, and secure infrastructure is crucial. Our system is deployed using Amazon ECS with AWS Fargate, which provides a serverless infrastructure. This means we do not need to manually manage servers. It ensures high availability, automatic scaling, and both cost and resource efficiency. We only pay for what we use, and resources are allocated as needed. Using cloud computing brings several advantages. Scalability, perfect for intensive AI tasks, handles challenging workloads with ease. Operational efficiency, automated resource allocation simplifies management. Demand based scaling, resources scale based on real time usage. Enhanced security, strong protection for sensitive data. No infrastructure overhead. Let us focus on research, not maintenance. Consistent environment, version control, and deployment are streamlined. Our system is modular and efficient, built on cloud infrastructure. Front-end interface, user interaction point. Query generator creates optimized search queries. Web scraper gathers relevant data. Summarization engine identifies knowledge gaps. Iteration engine refines the research loop. Report generator compiles and outputs results. Cloud deployment and scalability. Let's start with the deployment process. We first containerize our system using Docker, which ensures portability and consistent execution across environments. Once the image is ready, it's pushed to AWS ECR, a centralized image repository. Next, we create an ECS task definition, which allows us to run these images as tasks within the ECS cluster using AWS Fargate, a serverless compute engine. In terms of infrastructure, we begin by setting up a serverless ECS cluster which automatically scales based on the workload. We then define tasks specifying CPU, memory, and network, and Fargate handled resource allocation. Finally, service definitions help maintain container lifecycle and ensures high availability through continuous task monitoring. Load balancing and traffic management. For traffic management, we integrate an AWS load balancer with our ECS service. It distributes incoming requests efficiently across containers. We also enable health monitoring through a designated health route, ensuring that only healthy containers serve traffic. If a container becomes unhealthy, the system's self healing capability automatically replaces it without manual intervention. This setup guarantees continuous availability and resilience under load. Automated deployment for updates. Updates are seamless. When we update code, a new Docker image is pushed to ECR. A deployment is then triggered, typically under force new deployment. ECS replaces old containers automatically while ensuring that the new containers pass the health checks before taking over. This strategy minimizes downtime through safe rollout and provides failure recovery by keeping the old containers active until the new ones are verified. Resource management. Lastly, we ensure efficient resource cleanup to prevent unnecessary cost. This involves three steps: setting the task count to zero, stopping and deregistering the ECS service, and finally deleting the ECS cluster. This cleanup process ensures we only use the resources we need and release them when they are no longer required.
So I am going to walk you through the deployment phase. So here it is our Streamlit application. Uh, we have Dockerized it into a container. Here I will show you Docker images. So at the top, this is the AP South one. It is our Docker image, and we have pushed the Docker image to ECR, which is Elastic Container Repository, which stores all the uh, Docker images. So I am going to go on Amazon Management Console, where I will show you the ECR. So here it is our UCR, which is Uniform Resource Identifier, this URL. Now we go to ECS, which is Elastic Container Service, which uses this Docker containers for tasks. So in this Elastic Container Service, we have created a cluster named Dev Cluster. So in this Dev Cluster, we have a service called Deep Research Service. So service can be anything. If we have an e-commerce website, login can be a service. In that login, we can create many subtasks. So here we have created a task called Deep Research. So I created many versions. We'll see the latest version. So I have allocated 2V CPU and 6 GB memory. So here we can see our task. The task actually has the Docker image. Uh, this which was this Docker ECR image. So now we go to clusters. We go on clusters. We see a service called deep research service, which has this the deep research task ARN. Now we go on to this deep research ARN. We see that uh, the usage, the memory and CPU utilization. Now after that we go on task. So here we see the task with the ECR image URI and this container runtime ID and image digest, everything else. So we go on this task. You see the overview that it is using that ACR URI. It is using Fargate, which is a serverless computing service, and OS, CPU, and memory. And so we go on networking. We see that we have created a VPC. In that we have a subnet security group. So when we click on this security group, VPC console opens up. So in this security group, I have allowed everything UDP, TCP, HTTP, and everything. So the port mapping I've allowed for all the ports. So let me go back. So when we open this IP address, uh, the site will not open up because we need to target that specific port. That port was 8501. So on hitting that port, the site opens up. So here it is our application. And here we see the number of search results. So the number of search results are the number of sources that our model uses as a reference point on the web. So here it is the input box for the research topic. Suppose I enter this topic, system evolution analytics, and press on the research button. An API named SERPs goes on the web, fetches all the information regarding that topic, and a local model, Llama 3B1 instruct, summarizes all the information. So here it is the result, system evolution analytics, re- research summary, key findings, sources overview, further research directions. We can download the summary also here. And if we go on source information, we see the sources that our model use as a reference point. Here, your name comes also. If we go on the source, this page opens, which the model used to summarize the topic. So that's all from our side. Thank you.